In previous videos, we talked about overloading operators as member functions. So in this video and in upcoming videos, we are going to talk about overloading operators as global functions or as friend functions. We can overload unary and binary operators as global functions. This is what the unary operator prototype looks like when you declare it as a global function. I also have an example of the negation operator. This will return a vector2d. You can see we have operator, the negation operator, or minus. You will notice that when we overload unary operators as global functions, that they take in an argument. As member functions, they don't typically take in an argument. That's because the left-hand side operand can be accessed either directly or using the this pointer, right? It operates on the calling object. Remember when we had binary operators such as with the addition operator, you have a left-hand operand and a right-hand operand, and the left-hand operand was the calling object, and the one that you pass in was the right-hand operand. But again, since these are implemented as global functions, we do not have that hidden address for the calling object, or in other words, the this pointer, because it's not a member function. So when you overload a unary operator as a global function, you will typically have one formal parameter, and when you overload a binary operator as a global function, you will typically have two formal parameters. Just out of interest, we have the unary prefix increment operator and the unary postfix increment operator, both declared as global functions. Since these functions are global, we have to actually pass in the operand. And so with the postfix increment operator, we have the operand. Again, this is a unary operator, so we only pass in one argument. And then for the second parameter, we can do that integer. Here's an example of that unary negation operator. I'm using the vector2d struct again just as an example. This is how we overloaded it previously as a member function. It is const because we want to prevent changes or modifications to the calling object. We have a temporary object right here, and then we basically negate those members and then we return temp again. And this is what we did in the main function. I have vector1 and vector2. Vector2 I'm going to initialize to 15 for the x component, and y here will be 5. Here I do assignment, so I do the negation of vector2 and then I assign that to vector1, and then I simply print out the y components for vector1 and for vector2. We should get -5 and 5. Okay, so based on this, the y component for vector1 will be -5. Let's go and comment this out now. This is implemented as a member function, so let's go and implement that as a global function. Okay, so you want to do the negation of that. This should work fine now. Up here, of course, we do -x and -y to refer to the calling objects x and y members. You can also do this, the arrow operator, and then fit x and y that way, and then assign those. The negative of those, basically, you can assign to temp.x and temp.y. But in the global function, we do not have access to this, as I mentioned, so here we pass in that operand as an argument. We create a temporary vector2d right here, and then we assign the negative of operand.x to temp.x, and the same for the y component, and then we return temp. If we build and run that, and that works fine. Now we'll go and uncomment this member function here, the negation operator, so we have the member function now, and the global one as well. In main, we already have a red squiggly here. More than one operator matches these operands. And as you might expect at this point, you'll get an ambiguous error. The compiler doesn't know which one of those overloaded operators to use. What this boils down to is you want to overload these operators either as member functions or as global functions, but not both. As I mentioned, you can also overload binary operators as global functions, and here's an example of the typical prototype for a binary operator as a global function. You may remember that we overloaded the addition operator as a member function in a previous video. Now here, we are overloading the addition operator as a global function, and since this operator does not make changes to the operands, the formal parameters will be references to const. I'll demonstrate overloading the binary addition operator, and I'll use the entity class again for this example. This is how we overloaded the addition operator as a member function in previous lectures. Okay, we have a constructor, the addition operator, and then this toString function which simply prints out the member. For this example, the member is not a pointer, it is just an integer. Then in main I construct entity 1, I pass in the argument of 3, and entity 2 with the argument of 12, and then result as well. And in this assignment statement I'm simply going to add entity 1 and entity 2. That is going to use the overloaded addition operator. And this statement is going to use the compiler generated assignment operator, which is going to do simple member-wise assignment, and that's fine for this example because again we do not have member pointers. Then I simply do result.toString, and this should print out 15. Okay, I'll comment the overloaded addition operator right here that is overloaded as a member function. Okay, I'll comment that out. This is where we'll start to run into problems. Since this is not a member function, I have to pass in both operands, the left-hand operand and the right-hand operand as well. In the previous section, we used the vector struct to demonstrate the negation operator and how to overload that as a non-member function or a global function. Of course, with the vector2d struct, those members were all public, but here the member is private. Or should I say the x and y components of the vector2d were public, whereas here we are working with a class, and this member again is private. If you try and do the left-hand operand, and the dot operator of course will only have access to the public members of that class, in this case toString. What I can do is I can copy this header in this whole field with a semicolon. Okay, so you specify this declaration as a friend, so this global function or this non-member function is now a friend of this entity class, and therefore it can access the private members of this entity class now. Okay, I construct a new entity right here, and I pass in as an argument the result of this right here. I do the left-hand operand dot member plus the right-hand operand dot member. I call these parameters LHO and RHO for left-hand operand and right-hand operand. It's also very common to call them LHS and RHS for left-hand side and right-hand side, but because they are operands to an operator, I refer to those as operands, so the left-hand operand and the right-hand operand. But again, that's just a personal preference. And so this here should work fine now. Build and run, and that should print out 15. So as a recap, when you overload operators as non-member functions, and the arguments that those operators take in are objects of classes, then typically you want to specify that as a friend of the particular class, so that you can access the private members directly, because you do not always want to provide getters for all of your private members. That is going to wrap up this lecture. I'll see you next time.